Have you ever wondered if you could hop into a time machine and travel to any point in time and space? Time travel, a concept that has long held our fascination, is not just a staple of science fiction novels and blockbuster movies. It's an enigma that has also piqued the curiosity of the most brilliant scientific minds. From H.G. Wells' Time Machine to modern-day quantum physics, the idea of journeying through time has been woven into the fabric of our culture and scientific discourse. At the heart of this concept is the space-time continuum, a four-dimensional framework, combining 3 dimensions of space and 1 of time. It's a concept that's as complex as it is captivating, and it's central to our understanding of how time travel might work. So, time travel seems exciting in movies, but is it really possible? Let's delve a bit deeper. To understand the feasibility of time travel, we need to first grasp the concept of the space-time continuum. Imagine a sheet of fabric stretched out. This fabric represents the fabric of the universe, with its threads making up the 3 dimensions of space and the 4th dimension of time. This is the space-time continuum. Now, let's introduce Albert Einstein's theory of relativity into the mix. Einstein revolutionized our understanding of time when he proposed that it isn't a fixed entity, but rather it's flexible and can be altered. This is where it gets interesting. According to his theory, time can slow down or speed up depending on how fast you're moving relative to something else. This phenomenon is known as time dilation, and it's been proven through precise experiments with atomic clocks. But that's not all. Einstein also theorized that gravity can distort time. Picture our fabric again. If you place a heavy object on it, the fabric will bend. This bending is what we call gravity. The heavier the object, the more the fabric bends and the slower time passes. This is why time runs slower the closer you are to a massive object like a planet or a black hole. These concepts of time dilation and gravitational time distortion are fundamental in our discussion about time travel. Essentially, if we could find a way to manipulate these elements, we could theoretically alter the speed at which time passes for us. But before you sprint off to build your own time machine, remember that this is all theoretical. While Einstein's theories have been proven correct in various experiments, we still don't have the technology or the understanding to manipulate time on a large scale. This understanding paves the way for a theoretical possibility of time travel. But how could it be achieved? Stay tuned as we delve deeper into the mysteries of time in our next segment. The idea of time travel might not be as far-fetched as it seems. To understand why, let's delve into the realm of wormholes. These fascinating structures of space-time, if they exist, could potentially play a pivotal role in our quest to conquer time. Imagine a wormhole as a cosmic shortcut. It's like a tunnel with 2 ends, each opening to different points in space and time. Theoretically, a spaceship could enter a wormhole and emerge light years away, or even in a different era. It's a concept that has tantalized scientists and science fiction writers for decades. However, it's not as simple as jumping into a wormhole and popping out in the Jurassic era or the distant future. The reality is a bit more complex. For one, wormholes, as far as we know, are incredibly unstable. They could collapse in the blink of an eye, potentially trapping or obliterating anything inside. And then there's the matter of size. Most wormholes predicted by the theory of relativity would be microscopic, far too small for a spaceship or even a single atom to pass through. To keep a wormhole open wide and long enough for a spaceship to pass through would require a form of matter with negative energy density, something that's not known to exist. And let's not forget about time. While a wormhole could theoretically connect different points in time, we don't yet understand enough about the nature of time itself to say for certain how this would work, or even if it's possible. In short, while the concept of wormholes gives us a tantalizing glimpse of the potential of time travel, the scientific challenges are immense. We're still far from understanding these cosmic shortcuts, let alone harnessing them for time travel. It's a thrilling prospect, but for now, it remains firmly in the realm of theory and speculation. The concept of wormholes gives us a glimpse of the potential of time travel, but we're still far from making it a reality. Or while we can't pack our bags for a time travel journey yet, the future holds intriguing possibilities. The realm of quantum physics, a field that's as complex as it is mysterious, is spearheading the research into time travel. Its mind-bending theories and principles, such as quantum entanglement and superposition, hint at the possibility of time manipulation. Some scientists even theorize that these principles could one day enable time travel. Imagine if we could harness quantum superposition, a phenomenon where a quantum system can exist in multiple states simultaneously until observed. Could we then exist in multiple points of time, all at once, until we choose to observe ourselves in a particular moment? The very thought is exhilarating, isn't it? Advancements in technology and science are pivotal to this journey. We're already witnessing the birth of quantum computers, machines that leverage quantum mechanics to perform computations. Could these be the first stepping stones toward a future where we manipulate time? Yet it's crucial to remember that these are still theories and hypotheses. They push the boundaries of our understanding and challenge our perceptions of reality, but they're not concrete. The feasibility of time travel remains uncertain. The scientific community is divided, with some viewing it as a tangible goal and others dismissing it as fantasy. The potential implications of time travel are enormous. It could revolutionize our understanding of the universe. It could change the course of history. But it also comes with a multitude of ethical and philosophical questions. If we could travel back in time, should we interfere with events? Could we inadvertently cause more harm than good? There's also the issue of paradoxes. The infamous grandfather paradox poses the question: if someone were to travel back in time and accidentally cause their grandfather's death before their parent was conceived, how could they exist in the first place to time travel? So, while we may not be ready to jump into a time machine just yet, the mysteries of time travel continue to captivate us, making us wonder what the future holds. Time travel, a concept that has intrigued us for centuries, remains a scientific conundrum. We've explored its captivating concept, delved into the role of the space-time continuum and wormholes, and pondered over its future possibilities. As we stand on the precipice of scientific discovery, the enigma of time travel presents more questions than answers. While the feasibility of time travel remains uncertain, the exploration of this concept continues to push the boundaries of our scientific understanding, reminding us of the endless possibilities that the universe holds.